Good morning to all of you. Today we will start in this module the architecture of the smart grid system. If you could see here that in smart grid system we have 7 sections or 7 parts. The first part is the bulk generation, and the second one is the transmission system, third one distribution, and fourth one the customer. In general, the power is basically generated at the generating station, and this powers basically transformed from the generation station to the customer's end through the transmission distribution networks. And apart from these 4 sections, we have other 3 sections. If you could see here, this markets, operations, and service provider. And coming to the basically this is the very basic block diagram of smart grid architecture or layout. In this case, I will start from the bulk generation, and this bulk generation basically generates the power, and these generating stations are basically maybe the coal based generation, maybe hydro based generation, and also presently we have renewable sources as far as the smart grid is concerned. In this case also we have wind generation and solar generation systems. And this the major role of this bulk generation system is to generate the electricity in bulk quantities. And after this, the generated electricity or power is transformed to the transmission network and then distribution network and then the customers. If you could see here the markets, already we have discussed in the first part that this generation, transmission, distribution and customers are the very important part. Along with this, we have this market, operations and service provider. As far as the service provider are concerned, basically there are certain organizations which basically provide service to the generation system, to the transmission system, to the distribution system and also to the customers. And apart from that, we have also operations sectors, we have also market. In the market, basically the participants, they basically participate for selling or trading of the power. So, we will discuss slowly one by one every part very quickly. Welcome to the customer domain. In the customer domain, as I said, the customer is the end user part which consumes the power. This is where the electricity is consumed. And if you say these customers are basically of 3 types. The first one is our home customers, that is known as home equipments where we use the power, and second one is the commercial or building consumers where the power is consumed in the commercial buildings or commercial sectors, and the third one is the industrial power sectors or industrial consumers. If you could see the power range for home type of consumers, the power range is it is less than or equal to 20 kilowatt, and for your commercial buildings the power range is within 20 to 200 kilowatt, and similarly for the industrial part the power range should be greater than or equal to 200 kilowatt. This is basically the energy range. Based on the energy range, we basically classify the customers in this manner. Now, one point here I want to mention, that is the ESI, which is very important, that is energy services interface. What is that? It provides this particular system, this particular practice, it provides a secure and interface for the utility to customer interactions. This is a very important part of the architecture of the smart grid. Now, if you will come, it is a very consigned, very important figure I will say, where you could see all the customers together. You could see this is the building commercial part, this is the industrial part, this is the home, and these are all the service operation distribution markets. What I want to say from this particular figure it says that if you could see in every commercial, I mean the customer domain, maybe it is commercial, it may be industrial, or it may be home type of customers, everywhere the common thing is the metering facility, and we have a basically gateway. You could see here in industry also we have 1 meter, and also we have industrial gateway. And similarly for this home type of customers, we have home gateway and also the meters. And as far as the definitions of the smart grid is concerned, the major block of the major part of the smart grid system is the communication system, communication network. A dedicated communication system is very essential for flow of the data from one customer end to other customer end, or maybe from one part of the smart grid network to the other part of the smart grid network. Now, as I said, mentioned before 2 slides, that this ESI is the primary service interface to the customer domain. As far as the communication is concerned, for this ESI, this is very important, I just want to mention here, this ESI communicates with the advanced metering infrastructure. This is very important, and this infrastructure, advanced metering infrastructure, is very essential part of the smart grid system. And this is basically interconnected to the ESI. How? Through the internet, through the internet. And another one is also very important part of the ESI communication system, that is, it also communicates with the devices which are present inside the system through the home area network or the local area network, which is known as HAN or LAN. The HAN stands for home area network and the LAN stands for local area network. And coming to the basic block diagram of the customer domain, here it is. So, you can see, as I said, we have 3 types of customers broadly, like we have the commercial, industrial, and we have residential customers. And one more thing I have just added here, this is the micro generation. You could see here this micro generation is nothing, this includes all the type of distributed generations, that is also the part of customer domain. So, this distributed generation means we have solar system, we have wind system, we have fuel cells, also we have batteries. So, those batteries are also the part of the distributed generations. We will discuss more about in the subsequent slides or maybe in the subsequent models. And the main role of, as far as the customer domain is concerned, the major part is the building and home automation, we have industrial automation, we have micro generation, and their corresponding functions are defined here in very briefly. If you will see what is the function of this building and home automation, the major function of this building and home automation is to control various functions which is happening inside a building of the smart grid. And similarly, coming to the function of industrial automation, it controls the industrial processes, such as if you see in all the industries we have different types of functions, manufacturing and also warehouses, so many things. And coming to the another domain, this is the second domain I will talk about, that is the market domain, which is very important part again for the smart grid architecture is concerned. And here, as the name suggests, market means where basically we just, where the grid assets are bought or sold. The grid assets are bought and sold, that is the main target of market domain. Now, if you see, there are some high priority challenges. As far as the market domain is concerned, we have high priority challenges. What is the first challenge? The first challenge is extension of price and DR signals to each of the customer subdomains. This is the first high priority challenge. What is that? That means we have 3 types of customers domains, customer subdomains we have also, like we have commercial, we have industrial, we have residential customers. So, in that case we have to extend, we have to decide the price and DER signals, it should be properly judged, it should be properly monitored, it should be properly adjusted. And the second one is very important also, that is expanding the capabilities of aggregators. I will discuss more about in the subsequent part of this module. I will discuss what is aggregators. The aggregators means which helps to participate the DER small utilities to participate in the big markets of the power. So, where the power exchange takes place. So, in that case the expanding the capabilities of these aggregators, that is also very important part, function, challenge of the market domain as far as the smart grid is concerned. Now, we have interoperability. This is very important. Interoperability, this word I will discuss in detail of my slides, and I just want to say what is that actually. It means we have many devices, many equipments present as far as the smart grid is concerned. We have generation, we have transmission distribution equipments, we have customer premises, we have different equipments are present in the customer premises. So, in that case we have to, we will set in such a manner in the smart grid, we have to basically, they should speak to each other. Every device present in the customer domain, devices present in the transmission domain, distribution domain, they should speak to each other. So, that is what interoperability. Now, this is how the across all providers and consumers of the market information. What is happening inside the market of the smart grid, the information should flow to every part of the smart grid system. Now, this the fourth one is managing the growth and regulation of retailing and wholesaling of energy. This is also important. This is the one part of the challenging task as far as the market domain is concerned. Now, and the last one is also part of it, that is the communication mechanism for prices and energy characteristics. This is also very important. What is this energy characteristic? The energy characteristic is between throughout the markets and customer domains, because the customers are the end user. So, there we have to say what should be my energy characteristics, what should be the price of my energy which is going to be sold to the customers. Now, I will just come a very brief diagram, or I can say it as a very basic block diagram of the market domain. You can see here we have the sections of the parts of the market domains. This is the DER aggregation, and this part is market management, and this is the market operation, this is wholesaling, trading and ancillary services and retailing. So, these are the components of the market domain, right. So, these components are going to also access our transmission, customers, service provider, generation, distribution operations. As I said, in the smart grid system, all the parts, all the domains are interconnected with each other. That is very essential, which will lead to the name of smart grid, which was not available earlier, So, that is why this market domain is also linked to each domain of the smart grid system. This is the function of each domain. In short, I will just discuss that. I will start from this retailing. Retailing means here in this retailing section of the market domain, we will sell power to the end consumers. We are selling the power to the end consumers. These consumers will basically consume the power. So, this retailing part helps to do that. And also connected to the trading organization, this is also second function of this retailing part or retailing component of the market domain. And the second one is the DER aggregation. Already we have discussed this word, what is aggregation. The aggregation, nothing, the aggregators combine small participants in the market to sell their power to the, to the energy market, to participate in the energy market. That is what the DER aggregation. And next is our trading. In case of trading, we have this, it is a very important part of this market domain where we go for buying and selling of the energy. That is very essential part of our market domain. Now, of course, this market operation is also important, that what is the function of this market operation? The market operation basically function very smoothly, and basically the financial and goods which are used in this smart grid environment, what are the financial documents, financial affairs, or the goods which are sold inside the smart grid environment or system, and also the price quotation streams, edit balancing. So, these are all the part of, this is the major part of the market operations. And we have ancillary operation. In the ancillary operation, sometimes also we have to support the frequency and the voltage and the spinning reserve of smart grid system. So, this ancillary operations are ready to supply those support, that is a frequency, voltage and spinning reserve support. And coming to this market management, because every system should have some management system. So, this market management is also there to manage the ISOs. You could see here this ISO means the independent system operator. This market management block or this component of the market domain helps to manage the ISOs for their wholesale markets. So, these are very in brief the functions of the market domain. Now, I will come to the third part of the as far as the architecture of the smart grid is concerned, that is service provider domain. In this case, as the name suggests, service, we have to provide service to all the components, all the sectors, all the things which are involved inside the smart grid environment. That service provider, I will just define in very short. It supports the business process. The first part I will just name it. It supports the business processes of power system producer. The producer means it may be the generation, it may be equipment producer, anybody. So, we have to provide, this service provider domain will provide the business processes and distributors and customers. Yes, of course, because as I said, the power network has the basic building blocks, that is the generation, distribution and the customer consumption. That is, the customer is the last end part of the electric network. So, the service provider domain will help in processing the business of these three domains. And coming to another point which is basically involved in the service provider domain, that is, the business processes range from traditional utility services. This is important. The traditional utility services such as the billing, and we have customer account management, we have enhanced customer services such as management of use and home energy generation. See, these words are very, very important. Every word has a meaning. Like if you see that as I said here, the traditional utility services such as billing of the customer and customer account management, or this enhanced customer services, or management of energy use, how much energy is used inside a customer home as far as residential customers are concerned. So, those information basically should be maintained by this service provider domain. And coming to the challenge, what is the challenge for this particular domain? That it is very difficult to develop the key interfaces, these interfaces and standards that will enable a dynamic market driven ecosystem. This is this ecosystem, market driven ecosystem is our target. Without market driven ecosystem, so there is no existence whatever the service provider domain provides to us. So, we have to see that first, whether the things which are provided by the service provider system, whether it is ecosystem, it is economical viable or not, is it user friendly to the environment or not, and while protecting the critical power infrastructure. The critical power infrastructure should be intact, it should not be affected. Now, this is how this definition goes as far as the service provider domain is concerned, and coming to this part, the very basic block diagram of this service provider domain, what are the components of this particular domain? The first component, I will just start from here. installation and maintenance. Then the second one is the building management, third one is home management, and the fourth one is emerging service, and the next one is account management, custom management, and finally we have billing system. So, these are the essential components of the service provider domain in a smart grid system. And remember, this all these components of the service provider domain, these components or these sections also will speak to our markets, customers and operations through very dedicated communication system by exchanging the data between them. Now, this is how the functions of each components of the service provider domain, I mean the functions of each components are outlined in this particular PPT. You could see here I will start again the installation and management part. This is the first part. So, here what is the function of this in brief? It helps in installing, maintaining premises equipment. That is what the function of this installation and management component of the service provider domain. And similarly, I should not read all. You can see here this building management. In this building management section, we have the monitoring and control of all the building energy. That facility we should have, how the building equipments can be monitored and controlled time to time, that is a function, that is a part of this building management section. And similarly, the home management, and we have very important part is the billing part, because as far as the service provider is concerned, that the main part is the building. We have to manage the building, I mean the billing of the customers information. The customer information should be properly accessed. The bill should be prepared at the proper time. That is very important. Now, we have emerging services. The emerging services, basically we have all the services and innovations of the smart grid operation, future smart grid operations. What innovation we can do further to have a very reliable and accurate operation of the smart grid, very dependable and secure operation of the smart grid. So, that part is basically emerging services. What are recent trends, what are recent technology is evolved, with help of those technologies we can basically make our smart grid more accurate, more reliable, more secure in operation. And the last one is the customer management, where this customer management section maintains the relationship between the customers, how the customers relationship will be maintained properly in a fair manner. Now, the operation domain, that is the next domain of smart grid architecture, that is the operation of the smart grid system. I will say this particular domain is very huge if we will compare to other domains like customer domain or operation domain, that is your market domain. So, this operation domain is very important and it is very huge and it is a large scale domain, where it helps in basically it is responsible for smooth operation of the power system, nothing else. Our main target of this operation domain is to maintain, to operate, to monitor, to control the smart grid in a very secure and dependable and reliable manner. That is what this aim of this operation domain. And if you come here, this operation domain components, as we have discussed in the previous few slides, that exactly the same manner I want to say here that what are the components of the operation domain. In the operation domain, I will start from here. First one is maintenance and construction, and the second one is the financial part, and the third one is supply chain logistics. And yes, we have records, fourth one records and assets, and the fifth one is security management, and sixth one is communication networks, seventh one is meter reading and control, and yes, the last two is operation planning, this is 8, and ninth one is the extension planning. So, again I just want to say share with you that all these components of the operation domain communicate with other part of our smart grid system, that is your markets, service provider, customers, distribution, we have transmission. Yes, here the network operations, this is very very important, this part is very very important, this network operations very very important. That is where we have, I mean, how to operate the network very smoothly without any disturbance, without any hindrance, without any problem, because our aim is to basically flow the power, allow the power to flow from the generation station to the customers. That is our aim. That is why we are designing the smart grid in this manner. We expect that power should not be interrupted at any time and the quality of power should be maintained to the customers. That is how the aim of the smart grid. And of course, there are lot many, I mean, functions of the smart grid. In general, this is the statement, this is our aim. And yes, of course, with efficiently and economically, without disturbing our environmental issues. Our environmental things should be, I mean, maintained properly. So, that is how this operation aims, and all the components help for proper functioning of the operation domain. And you could see here it is a very big chart, and I will try to summarize nicely and easily, I mean it is a very simplified manner. If we come to this monitoring part of the operation domain, in the subsequent modules we will learn how to monitor the smart grid system using phasor measurement unit or wide area measurement systems. Those are the equipments. Yes, in recently there are a lot of projects are also running on this monitoring system of the smart grid. And earlier we basically use the SCADA system. We will also discuss in the module of components of the smart grid. So, those equipments like SCADA or PMU or WAMS, so those components or equipments or systems provide the monitoring aspect. In the monitoring system basically supervise the network connectivity, how this network is basically connected with each other, how the power is flowing, how the frequency is maintained, how the voltage is maintained. So, those aspects are going to be basically supervised using this monitoring component, monitoring section of the operation domain. Now, we have, of course, after the monitoring we have control, how to control those equipments or the generating stations or the distribution network, or it may be transmission network, or it may be a storage device. You can name anything in the smart grid network, how to control those equipments. So, the control section will take care of this. That is what it is written here, supervise wide area and local automatic or manual control. To make it clear that in the smart grid era we are not anymore dependent on manual control, rather we are going to be dependent completely on this automatic control system. And the third one is the fault management component. This fault component, I mean the fault management system, basically it helps in identifying the fault which is being incepted in the smart grid system, and also it helps in elimination and further the service restoration. You can see the fault is very, it is inevitable, it can come to at any time, you cannot basically control the fault. It will not provide any basically some notice that I am going to, I mean to be present, I am going to present at this time and this day, it is very uncertain. So, the fault is basically the, I mean the main part, the major disturbance which is expected in the smart grid system. So, those major disturbances should be taken care, it should be detected, it should be maintained, it should be repaired, and again the service to the customer should be restored. Now, the analysis obviously, because whatever we are doing, the very important part is we have to analyze the system, operation, control, monitoring, fault detection, every part should be analyzed properly, whether it is proper according to the standard, according to our desire, for what this equipment is designed to operate, whether it is perfect. So, those analysis is basically, those analysis are must in the smart grid system, and reporting, statistics, calculations are part of this analysis. Now, coming to this part, the training, real time network calculation actors training we need, and also the records asset. It provides the facility for dispatchers that simulate the system, these records and assets. And this is the another part, that is the operation planning. This section basically provides the track and report on network equipment inventory. That is the function of this operation and planning. What kind of planning further we can do? What planning is necessary further? Yes, of course, what smart grid layout is presently operating, so that we cannot change, but from the analysis, from the operation analysis, from the record analysis or data analysis, what further extra things we can embed to this particular smart grid network for further smooth operation. Yes, I always say, I will say one sentence, that our target is the smooth operation of the smart grid system. All these components are basically designed for that purpose, for smooth operation of the smart grid system. Now, the three sections left out, that is the maintenance, construction and extension planning and customer support. I will discuss about the last one, this customer support is very important, because we should help to the customers for troubleshoot power system services, because the customers are the main part of the smart grid system. If we have generation, we have transmission, we have distribution, but there is no customer, so there is no use of the power. The customer should be satisfied first. If any trouble at any time comes to the customers, then we have to rectify it through our automatic process, or we have to reach to them through our manpower. So, that is what this customer support part. Now, I will just come to the another domain of this smart grid architecture, that is the bulk generation domain. And as the name suggests, the bulk generation domain helps in generating the power. We have in our country, we have hydro based power stations, we have coal based power generations, we have also nuclear power based generations, and also we have very quickly, rapidly we are moving towards renewable power generation. That is very essential today's, as far as today's market is concerned, or today's age is concerned. So, we have to be fully dependent on renewable energy as quick as possible. There are lot many issues are coming up, like we have carbon dioxide emission target. We have to limit the carbon dioxide emission within certain limit. That limit we should not cross. That because our main generation is from coal, that is around 60%. So, we have to be very careful, we have to generate the power from the renewable sources more, like wind or solar or fuel cell. So, mainly our target is solar and wind systems. So, what is this domain function? How this basically the bulk generation domain helps in the smart grid system? This is the, I have just written three parts. I have divided the function of this bulk generation domain into three parts. The first one is the electricity generation is the process of creating electricity from one form to other form. As I said, it may be nuclear fission, flowing of water means it is a hydro based generation, wind, solar or geothermal, already we have discussed. So, these are the sources from where we will get the power. And what is the function then? The boundary of this bulk generation, this bulk generation domain is typically the transmission domain. It will just send the power to the transmission domain, and this bulk generation domain is electrically connected to the transmission domain and shares interfaces with operation, market and transmission domains. We will discuss about these transmission domains after this. So, this basically this bulk generation domain interacts with the operations, the markets and the transmission domains. It shares interfaces. This is very important, this one. It has a connectivity basically between this particular operations, markets and transmission domains. Now, I will come to the last one. What is the new requirement for this? That is, it is obvious, it is also happening before also, because the bulk generation domain should interact with the transmission domain, it should also interact with the service domain, it should also interact with the market domain for its smooth operation. What is the new thing happening in this domain? As far as the smart grid is concerned, the main requirement for this bulk generation domain include the greenhouse emissions control, which is very important. As I said before few minutes, in our country our full demand, our full power generation, we are aiming from the coal, 7% from the renewable sources. How quickly we can make this 7% to 70%, hopefully in near future we can make it 100% if possible. That should be our target, that should be our effort. So, this bulk generation domain will help us to reduce, how quickly this greenhouse gas emission control should be there, how this carbon dioxide emission should be controlled, it should be reduced. Unless until we use renewables in a huge manner, as well the percentage of the renewable energy is not going to be increased, we are nowhere, we are not going to reduce the carbon dioxide emission anymore. And also it helps in increases in the renewable sources, that is what our discussion, and the provision of storage to manage the variability of the renewable generation. The last one is also important. Nowadays we have many projects are basically happening between US, India, UK, India to have very good technology for the storage purpose. Because if we will have generation from the renewables, so how quickly, how nicely, how easily, efficiently we can store the energy inside a storage system. That is also one of the major thrust area. So, these are the things functions of the bulk generation. Now, coming to this block diagram of this bulk generation domain, already we have discussed more or less, and I will say, as I said, we have renewable sources like solar, wind, hydro, biomass, geothermal. So, these are all the renewable sources which are also part of this generation domain. Along with this, we have also, like if it is a very sunny day and my load requirement is very less, where to go, where this energy which is produced from the solar we have to store. So, we have to store using this particular pump storage. The pump storage basically is storage part of the network, where we can store the energy, again when it is required we can use it. Also we have different storage parts in our system. Now, what is this? We have gas, coal and nuclear based. These are all non-renewable or non-variable energy sources, which are also part of this generation domain. And remember, this generation domain also speaks with transmission, markets and operations. Already we have discussed, these are also components of the architecture. As per the architecture of the smart grid is concerned, that is your operations, your markets and your transmissions. So, this generation domain also speaks to these three domains. One is the operation domain, market domain and the transmission domain. And this is how the functions of the components of the bulk generation system. One is the control, measure, protect, record and assess management. I will just emphasize these three. Record is obvious because whatever we are doing we have to record, we have to store the data for our future analysis or maybe for present analysis, and also we are storing the data for online challenging task. Online basis we have to take some decision, those data also will help us, and similarly the assess management. But of course, the major part is the control, measure and protect. So, these three parts are very, very important. In the bulk generation domain, we have to measure the data, all the quantities, the basic quantities, voltage, current, and further the derived quantities, frequency and power. So, we have to basically measure those data using maybe some, nowadays we are using the WAMS technology, and also the SCADA systems also are used till this date. So, we have to basically make it more, accurate and more faster, and WAMS is one of it. So, with help of those equipments, we will measure, we will store, we can monitor the things, the data, power flow or voltage or current or frequency information. Now, as far as the control part is concerned, we have to manage the flow of power and the reliability of the system. This is also important, because as you know, without reliable operation, without any proper flow of the power, there is no question of standing of the power network, it will collapse. The power flow should be maintained properly, the generated power should be equal to power demanded, that is must. To make the frequency constant 50 hertz, the power generation should match to the demand. If any mismatch is there, so there will be fluctuation in the frequency. So, we have to be very careful. So, that can be done this by using this control system. And yes, of course, the last one is the protect. The protection part is also important, very, very important. Without helmet we cannot play cricket, we should not, because some protection is very, very essential for our body. So, similarly, for all the equipments which are installed in the generation system on the smart grid, it should be protected. So, protect the system from various abnormal events. Coming to the another domain, that is the transmission domain of the smart grid system. It is very clear, as the name suggests, it transmits the bulk power which is generated at the generating station to the customer end through the distribution lines. That is what the transmission domain function. It transfers the electrical power from generation sources to the distribution through multiple substations, of course, because if you see our generating station voltage within 20 to 23 kV, it is going to be stepped up to 400 kV. Again the 400 kV is going to be stepped down to 230 kV, further 132 kV, then 66 kV, then 11 kV, then 440 volt at the customer end. So, this steps which are maintained from your generation to the customer end. So, basically the transmission helps in transferring the energy from one generating station to the customer end, of course through different substations. Not exactly, we are not transferring the power at 400 kV from the generating station to the customers. We have to scale down the voltage, then the power will reach to the customer end. Now, this transmission network is typically operated by two things. One is the regional transmission operator, that is known as RTO, and or it is also known as independent system operator, that is it stands for ISO, independent system operator, whose primary responsibility is to maintain the stability in the electric grid. How the stability will be maintained? It is going to be maintained by balancing the generation and the load. If these two are balanced, if our generation is matching to our load, the system will be stable, frequency will be stable and the voltage will be stable. So, then only we can say the system is stable. That is what these two sections like RTO or ISO, but these two names you can see here, basically it helps to maintain that. Now, this another part is energy and support ancillary services. The ancillary services already we have discussed in the generation part, that the frequency support, voltage support, spinning reserve, and are procured through the markets domain. In the market domains we have these ancillary services which are available, they can also procure from there, and scheduled and operated from the operation domain, and finally delivered to the transmission domain, to the distribution and the customer domain. We could see here, I just want to say, as far as the functions are concerned, domains are also different. But however, at the end of it, you could see here all the domains are interconnected with each other. Without help of one domain, other domain is layout, a layman, blind. So, without the help of transmission domain, generation domain is layman. Without the distribution domain, transmission domain is useless. So, that means all the domains are interconnected with each other, they help to each other. So, today we will stop here. So, in this particular module, we have studied the architecture of the smart grid system, and the corresponding components of this architecture are, first one we have discussed about the operation, generation, market and transmission. These are the major domains of the smart grid system. And further in the next slide, next module, we will discuss about the standards of the smart grid system. Thank you all.